So today we're going to look at solving rational equations. So the stuff that we've been doing so far over the past several days have just been adding and subtracting rational expressions, multiplying and dividing rational expressions. We haven't solved for anything. So if you think back to all of the questions that we did on this page, we didn't solve for anything, we just simplified. So we just tried to find how to simplify this the best as possible. So we did that for all of these questions. What we're going to do now is we're actually going to solve. So one of the methods we're going to use today are a little different from what we've done on the adding and subtracting page, but I'll talk about it when I get to it. So there's two methods of solving. The first method of solving is using a proportion. So if you can condense into a proportion, which is one fraction equal to another fraction, you can pretty much cross multiply and then solve. So that's the only time you can use proportions, if you have one fraction equal to another fraction. If that's the case, then you can use this method and solve. The next method over here is using a least common denominator. This should sound very familiar because we just did that on this page for adding and subtracting rational expressions, complex fractions. We did all of that for finding a least common denominator. So the same processes that we did as far as finding that least common denominator on this page and really all of the other pages we did here are going to help us with finding our answers. So when you're finding a least common denominator, we're going to multiply each side of your equation by that least common denominator and solve. So this part is a little different. You're going to multiply each side of your equation by your least common denominator and then solve. This is a little different from what we've done before. With the stuff we did, for instance, on this page, whenever we were finding a least common denominator, that was to make it to where both of your fractions were the same. What we're going to be doing instead now is we're going to be multiplying both fractions by whatever this least common denominator is. That's what we're going to be doing. And the last thing that I kind of want to change my highlighter for is to always check for any solutions that you're going to have. All of these solutions will hopefully have a correct place on your, I guess like a correct solution. But if it doesn't, that means it's extraneous. So we do have a possibility for extraneous solutions here. So be careful. All right, I'm not going to do every single question here, but I am going to start with question number 1. If I look at question number 1, just by looking at it, so just observe. Just by looking at question number 1, Caitlin, do you think we're going to follow method 1 or method 2? Method 1. Why? Because it's a fraction equal to a fraction, so we're going to use this first method. So it says to condense into a proportion, which this one already is, and then we can cross multiply. So we're literally going to multiply r minus 1 times 4, and we're going to set that equal to r times r, which is r squared. Once we do that, Caitlin, what can you do from here? You've done the cross multiplying. Here's the fun part. Here's the solving. How do I solve this? What does that parentheses usually mean? What that for? Okay, we could distribute. So we're going to make this 4r minus 4 is going to equal to r squared. Since you have an r squared, there's two different things you could do. A lot of students last class period told me, oh, we could square root both sides. Why can you not square root both sides for this question? Say it again. The r. This r right here, absolutely right, Alex. Because of this stupid little r, you cannot do the square root method here. The only time you can do it is if it looked just like this. And even then, with that negative, it would actually give you an imaginary solution, but we're not going to go down that rabbit hole. So we can't do the square root method. Caitlin, what's another way of solving a quadratic equation? Begins with the F. We can factor it. So what I'm going to do is I'm going to make all of this equation equal to 0, and I'm going to solve. Since this r squared is already positive, I'm just going to do the extra step and move these two terms to the right-hand side so that way I can just solve it pretty quickly. So I'm going to subtract 4r on each side, and I'll also add 4 to each side. I could split this into 2 steps, but 1 step is fine. So r squared minus 4r plus 4. And then just like Caitlin said, we're going to factor, not square root. So I'm going to make my little X chart. I'm going to multiply or find two numbers that multiply to positive 4 but add up to negative 4. I know I can get 2 and 2, but since I want to add up to negative 4, I can make both of them negative. Double check. What's the leading coefficient in front of r squared? 1. It's just a 1. So since it's a 1, I'm going to rewrite both of my binomials as r minus 2 and r minus 2 equals 0. Elias, is there another way I could write r minus 2 times r minus 2? What does that squared mean? Say it again. You're multiplying it by each other. So there's pretty much two of the exact same binomials. That's why we were able to condense this into one big parentheses. So technically, Elias, am I solving two equations or just one here? Okay, so with that r minus 2, we're just going to take that r minus 2 and set it equal to 0. You're just solving one of the equations, guys. You don't need to solve both. By having both of these r minus 2's like this, it's just one big equation that's going to give you the exact same positive 2 for your answer. So r is going to equal positive 2. Elias, am I done? Look at the top. Am I done? After we cross multiply, it says to solve. I've done that. Am I done? Always remember to check your solution. So over here to the side, I'm just going to go ahead and check this. I'm not going to do question 2 with you guys, so if you need to use some of the space over there, that's okay. We're going to take this answer that we just solved for and use the original problem. So 2 over 2 minus 1 is going to equal 4 over 2. All right, well, on that left one, I'm going to go ahead and subtract. So this is just going to be positive 1 in your denominator. And 4 over 2 simplifies to just 2. I want you guys to make a quick note. I am not solving anything. I'm not moving something from this side over to the other or vice versa. I'm just simplifying the left-hand side completely and then the right. Question, is 2 equal to 2? Yes. So what does that mean about r equals 2? It's your solution. That's your answer. So the only answer you're going to have here is positive 2. You would do the same exact thing for question 2. So in an effort not to waste your time or mine, we're going to look at example 3 next. So for example 3, which is down here, and I'll also make my note, r equals 2 is my solution for that first question. And I'll go ahead and move down here. All right, this question. Take a second and look at it. Just look. Elizabeth, can I do the proportion thing here too? Say it again. No, you can't. Okay, so especially since it's not one whole fraction equal to another, I don't think we should probably use that. So this 2 right now is over 1. Method 2 specifically states that we need to find a least common denominator. So for question 3, what's going to be your least common denominator, Elizabeth? I'll refresh your memory before you answer that. Having a least common denominator, we just pretty much found whatever denominator would make both of them the same. So for this one, we just multiplied both of these binomials to get the least common denominator. Same thing for the question over here. In order to get both of these to be a least common denominator, we took what was missing and multiplied it. So what would be a good least common denominator here? Just x. That's it. Just x. So double check, guys, and I'm going to tell you now, laziness is not your friend today. If you do not do the exact same steps I'm going to do, you're going to get very confused later on. Follow the exact same steps that I'm doing to avoid confusion. So just like Elizabeth said, we're going to use the least common denominator, which is x, and I'm going to multiply it by every single term. So that means I'm going to multiply x by this first term, x by the second term, and x by this last term. Really quick. This x is assumed to be in your numerator. So you're just putting that x over 1. I never put it over 1 because you're just going to change the numerators. So the first thing you're going to write is 5x over x because x times 5 is just 5x. 1 times x is just x. You're not changing any of the denominators. I will say this again. You are not changing any of the denominators. I'm going to multiply the next one. So you're going to have 2x over just 1. You can leave that 1 there. And we're going to set that equal to 6x over x. Elizabeth, take a look at everything. Is there anything that I can cancel? The x's. First 2 and last 2. Those x's. Really quick, Elizabeth, by having this over 1, is that really dividing it by anything? No, it's just there for decoration. So let me rewrite what I have. Let me actually simplify that a bit to a smaller line. We're going to make that 5 plus 2x is going to equal 6. This is what you're solving. If you keep that denominator, it's just going to make a big mess for you. If I were you, get rid of each of those denominators, and the way to get rid of each of those denominators is to multiply all of the fractions by the least common denominator. It will cancel each one of them. Give me a nod or shake. Does this make sense with what I'm doing? All right, so from here, we're just going to solve. So I'm just going to do two things. I'm going to subtract 5 on each side. So 2x will equal 1. And then I'll divide both sides by 2. So x is going to equal 1/2. Elizabeth, before I move on, am I done? I still need to check. So let me zoom out a bit. And I'm going to rewrite the original problem to check it. So 5 over 1/2 plus 2 equals 6 over 1/2. You don't need to put this 2 over 1. If you want to, you can, but it's not going to change your answer. Chris, how would I simplify these two ugly fractions? What would I need to do? You have a whole number divided by a fraction. And if you wanted to, you could rewrite 5 as 5 over 1 divided by 1/2. How would you divide that? Keep, change, flip. Multiply it by the reciprocal. So 5 over 1 times 2 over 1. What's 5 times 2? 10. And 10 divided by 1? It's just 10. So my first number, let me zoom back out, up here is going to be 10. I'm going to do the same thing for 6 divided by 1/2. So I'm going to move it over here. 6 over 1 times 1 or 2 over 1, because I'm just flipping that fraction. 6 times 2 is going to give me 12. So up here at the top, 6 divided by 1/2 is just 12. Perfect. This would be my answer. So with that being said, x equals 1/2. That's going to be my solution. So make sure you have it exactly how you should see it. All right. So we're going to use this exact same process. So I know it's a little different from expressions that you've had, and don't think, oh, well, if that's the case, I could use this method for every question that I have on this page. Expressions and equations are two completely different things. The method that I did for expressions, keep it with expressions. The method that I'm using here for equations, only use it for equations. Do not try to go between both. And I know somebody's not paying attention, so they're not going to listen, and they're going to miss this question on their tests and quizzes. So only use this method that I'm doing here just for equations. All right, next one we're going to look at is question number 4. For question number 4, we're going to do the same exact process. First thing I would recommend doing is looking at everything, just observing it first. Okay, so by observing it, one of the things I notice is this is already kind of distributed. It looks like they probably already multiplied some things to get to this. What could I do here to make it look a little more simplified? What could I do? I can take out an x. With that being said, Andrea, what's your least common denominator here? X times x plus 1. Perfect. So I'm going to take that x times x plus 1, and I'm going to multiply it by this entire equation. I'm telling you now, laziness is not your friend today, guys. If you're not willing to rewrite it, you're going to be really miserable when it comes to your homework. I'm going to take this entire problem, everything, and multiply it by x times x plus 1. I do the exact same process, exact same steps when you get to pre-cal. So I'm going to take this and I'm going to distribute it to each numerator. So let me rewrite what I have. In my numerator, I'm going to rewrite 3 for that first fraction times x plus 1 over x times x plus 1. Don't get it twisted, guys. I'm not changing the denominator that was already there. It was already x times x plus 1. I just recopied it from the original. That's all. For the next one, same thing. So second fraction, 3 times x plus 1, all over just x plus 1. I'm not multiplying this by the numerator and denominator. I'm not doing that. I'm just multiplying it by each numerator. And then for the last fraction, same thing. Negative 1 times x plus 1, all over just x. Andrea, can I cancel anything? First fraction, what can I cancel? Second fraction? Last fraction. Perfect. So let me rewrite what I have left. We have just a 3 for that first fraction In the second fraction, we have a 3x. And then in that last fraction, you have a -1 times x plus 1. A lot of students ask me, Ms. Tapia, can I just distribute that -1? Yeah, you can do that. Just don't forget to actually distribute it. So down here, I'm just going to go ahead and distribute really quickly. I'll just rewrite that as a -x instead of -1. So -x, and then -1 at the end. I'm going to do two things to simplify. I'm going to add x on each side, and I will also subtract 3 on each side. So I have 3x plus x will give me 4x, and -1 minus 3 is -4. Once you can get rid of all of those ugly, disgusting denominators, it's a lot easier to solve. That's why I have you guys get rid of those first. So I'm going to divide both sides by 4, and your x value should give you -1. Andrea, I forgot. Am I done? What do you still have to do? I have to still check it. So right next to it over here, I want you guys to do the check step. Take that original equation that you have, plug in that -1, and simplify. So we have 3 over 0 plus 3 over 0 equals 1. Really quick, if you divide 3 over 0, what do you get? Oh, thank you, Chizara. Undefined. Is undefined, Chizara, the same thing as 1? No, it's not the same. So even though this is undefined, guys, that's not going to help me for my answer. That means -1 is not going to be a solution. It's going to be extraneous. It's not going to be part of your solution set. So Chizara, do you have any other x value that we can try to check? How many x's did we solve for? Just one. We just had 1. It was just 1x. So is there any solution for this question if we already removed our only one? There's no solution. So up here at the top, I'm going to write out no solution. Be careful with that, guys. If you use your only answer and you check it and it doesn't work, it's not going to be a solution. All right, let's go ahead and look at question number 6. Number 6 is a little different. I purposely have you guys pause and just look, mainly for this reason. So for question 6, just look at it. Alex, what are you thinking besides that you want to go home? What are you thinking? Okay, there's a difference of squares. That's perfect. Anything else? Say it one more time. There's 2x minus 3's. If you look in both of these denominators, guys, they're both x minus 3, right? Okay, so let me first make a little quick change. Let me make this a plus -4 just to make sure you don't lose that negative. But yeah, both of those x's minus 3's are the same. We talked about this when we were adding, subtracting rational expressions a couple of days ago. Whenever you're doing that, what can you do here, Alex, with both of these? You can add them or subtract them. So we're just going to combine them. So go ahead and combine those. What am I going to write? And that's going to equal 8 over x squared minus 9. I like how Alex had seen that there was a difference of squares, but you don't want to necessarily just start factoring everything right away, especially for questions like this. There are multiple ways to solve this question, guys, but if you can combine both of your fractions into one, that would be ideal because you can now cross multiply. So I'm going to give you about a 2-minute head start. I want you guys right now to cross multiply. So multiply this and set it equal to the product of this. I'm going to give you about a 2-minute head start. All right, so let's see what stuff you should have hopefully started out correctly. So we're going to make this 8x minus 24 is going to equal -2x squared plus 18. And I definitely want to try to isolate this. I'm going to move these two items to the other side. And if you moved them, or if you move the 2x squared to the left, that's okay. This is one way of solving, guys. There's multiple ways to solve this. And then I'll also add 24 to each side. So we have 0 equals negative 2x squared minus 8x, and then 18 plus 24 is going to give you positive 42. One thing you should notice here is that between all of these numbers, the 2, the 8, and the 42, you can factor out a negative 2. Especially that negative. That negative you should definitely factor out first because you don't want this to be negative. So I'm going to leave in the parentheses an x squared. Every sign in here will change, so it'll switch its sign. So the negative x squared become positive. This will now be a positive 4x and a negative 21. This is what I'm going to factor. So down here in my little x chart, I need to find two numbers that multiply to negative 2 but add up to 4. Which two numbers can I use? 7 and negative 3. Since that number needs to add up to a positive 4, we're going to make that 3 negative. And I purposely took out a negative here from that x because since your leading coefficient now is a positive 1, you can just rewrite both binomials. So I'm going to rewrite what I have. Negative 2, which was the GCF that I factored out. We're going to take that x plus 7 and the x minus 3, and we're going to set that equal to 0. When I get to this point, a lot of students ask me, what do I do with this negative 2? My question to you guys, do you see a variable with this negative 2? No. Since there's no variable with this negative 2, consider it like decoration on your plate when you were younger and you wouldn't eat your vegetables. Yeah, that's a vegetable. You don't have to eat that. So what we're going to do is we're just going to leave it just like that, and we're going to keep x plus 7 and x minus 3 and set those equal to 0. I'll give you another minute. If you haven't finished solving this, solve it, and then I'm going to quickly double check to see if these are actual solutions. All right, so for question 6, you should have two solutions, x equals negative 7 and x equals 3. What I need to do now is check to see if both of those solutions are correct. So I did my check step over here to the side, and I checked first negative 7. So this top part up here is for x equals negative 7. That's the first part. So one thing I noticed, and double check my work, but I think negative 7 looks like a good solution. Both of those sides will be the same. It's ugly because it has a fraction, but negative 7 should be a solution. My issue, and I hope you guys can help me with this, is with positive 3. I know that 9 minus 9 down here is going to give me 2 over 0 plus negative 4 over 0, and that's going to equal 8 over 0. Anything divided by 0 is what? Undefined. So technically on each side of this, and I have students tell me, oh, well, it's undefined equals undefined, and that's okay. If it's undefined, is it defined? No. Undefined means that it doesn't exist. It's not going to be a solution if you were to graph it. It wouldn't be on your curve. So what I'm going to do over here for 3, yes, I know that undefined equals undefined. It's the same, but it doesn't exist. It's not defined by definition. So over here to the side for x equals 3, I'm going to label this as extraneous, and I'm only going to use at the top of the page x equals negative 7 as my solution. So up here, x is going to equal negative 7. That is your only solution for this question. Give me a nod or shake. Does that make sense why undefined does not equal undefined? Like, it's not an answer. It's cool that it's the same, but it's not an answer. All right, let's go ahead and look at question number 7. For question number 7, I'm going to go ahead and do something really quick. I'm just going to change this to a plus negative 4. And I'm going to have you guys, don't get too far ahead, but I'm going to have you guys try to figure out what is your least common denominator. Don't yell it out, just write it down. All right, so looking for this one. Nicholas, what's your least common denominator here for question 7? No, not negative 1. For question 7, what's your least common denominator here? And if you need to think back to when you were adding and subtracting, whenever we saw that both of our denominators weren't the same, how did we get this for this question? What did we do? Multiply by the pretty much both of the denominators. So what do you think you're going to do here? Same thing. So what's your least common denominator? The process, guys, is the exact same from what you've already done. The only difference is it's now an equation. So I'm going to go ahead and rewrite this as x over x plus 2. Rewrite everything, guys. Do not be lazy. This is not the day to be lazy with me. You're going to multiply this entire equation by x plus 2 and x minus 2. Everything. Every fraction is going to be multiplied by that x plus 2 and the x minus 2. So that first fraction is going to become x times x plus 2, x minus 2 over x plus 2. That's the very first fraction. Plus the second fraction, you're going to keep that negative 4, and you're going to multiply it by x plus 2, x minus 2. Keep the denominator the same. And then the last fraction, you're going to multiply that 2 by x plus 2, x minus 2. Nicholas, quick question. Did I change any of my denominators down here? No, I only changed the numerators. Those are the only things I changed. So, Nicholas, I have my fancy pen. What can I cancel on the first fraction? Second? Last. Nothing. You can't cancel anything, and it's okay. So let me rewrite everything that I have. Guys, the easiest way you guys can mess up is not being thorough with your steps. So x times x minus 2 is left in that first fraction, plus the negative 4 times x plus 2. And the only reason why I put this negative 4 in parentheses is so you don't lose that negative. That's the only reason why I put it in parentheses. And we're going to set that equal to 2 times x plus 2 and x minus 2. We're just going to have to multiply. This is not rocket science, guys. We're going to distribute that x here. So this will be x squared minus 2x. This plus negative 4, well, this is just going to turn into a negative because both of these signs, you can't keep both. You're going to keep the negative. So negative 4 times x, negative 4 times 2, we're going to multiply that. So this will give me negative 4x minus 8. And we're going to set that equal to, really quick, what you would technically do, and look up for this because I had somebody mess up last class period. Do not distribute this 2 to this fraction, or excuse me, this binomial and this binomial. Don't distribute it to both. If you distribute it, only distribute to 1. Once you get the answer for that, then take this result and multiply it by this binomial. That's how you technically FOIL it. But if you look at both of these binomials, what do they look like? Difference of squares. So with that being said, Alex, how would you write this if it's a difference of squares? X squared minus 4. If you have little shortcuts like that, and I will sometimes put those Easter eggs in your homework and tests and quiz questions, make sure you just do that step. That's okay, because I know when you FOIL this out, you're just going to get x squared minus 4. All right, let me distribute the 2, and while I'm distributing that 2, I'm also going to combine these two like terms here on the left-hand side. I'm just simplifying. So x squared minus 6x minus 8 is going to equal 2x squared minus 8. This is what you're solving. So right now, solve this equation. You're going to have to factor. Do not use the square root method. And then check your solution. All right, so one thing you should notice when you're solving this question, when you isolated everything and you tried to factor it, guys, the most basic of concepts you guys learned are usually what I always revert back to. So notice that when you move the 2x squared to the other side, you're just left with the negative x squared. And when you move the 8 to the other side, the 8's on both sides of your equation are going to cancel. So you should be left with this item here. Whenever you have something like this, how do you factor it? What do you need to do? Say it again. Take out the negative for sure. And then what else, Desiree? An x. Both of those terms have an x in common. This was the first type of factoring you learned how to do before we started doing the more complicated stuff. So x plus 6 is going to equal to 0. This is what you should have solved. So you should have had negative x equal to 0, which means x is just going to equal 0 because you're just going to divide both sides by that negative. And then x plus 6 is going to equal 0, which means x would equal negative 6. These were your two solutions. When you check both of those solutions, both of them are going to work. This one up here, or excuse me, down at the bottom is for x equals 0. And then the one at the top is for x equals negative 6. Both of these are going to be solutions. So down here at the bottom, I'm going to go ahead and highlight both of my answers. X equals 0 and x equals negative 6. Both of those are going to be solutions. Guys, I'm telling you now, if you don't get rid of your denominators like I'm doing, you're more prone to make mistakes. And if you don't show every single painstaking step for all of these questions, you're not going to get the credit. You have to do all of the work to get your credit. Before we do anything else, I want you guys right now, I'm not doing any part of it with you. I want you guys to do number 5. I would definitely suggest trying to find a least common denominator. And I do think it's appropriate for you to actually multiply or factor that. So go ahead and get started with question 5. So the first thing I would definitely do is see if you can factor this. So if you make your little X chart, oops, let me actually use my pen, off to the side, that you need to find two numbers that multiply to negative 10 but add up to 3. Well, the only two numbers I know that will do that are going to be 5 and negative 2. So I could rewrite this as x minus 2 and x plus 5. I will mention this before I kind of continue. I have had students ask me in the past if we move this to the other side by subtracting it and then create one big fraction for it, can we use proportions and cross multiply? Yeah, you should definitely be able to. But if you don't feel comfortable with it and you're afraid of moving equations around and things of that nature, you can just leave it in its current form and still get the exact same answer. So moving on, we're going to go ahead and rewrite this. And I need to go ahead and find out what that least common denominator is. So if you look at your denominators, you have an x minus 2 pretty much in every one of them. So that's definitely a part of your least common denominator. And then the other part is that x plus 5. These two fractions do not have one, so they're going to need one, x plus 5. So we're going to go ahead and multiply this entire problem by x plus 5 and x minus 2. All three of those fractions will be multiplied. So that first fraction, this guy here, is going to turn into 2 times x plus 5 times x minus 2 all over x minus 2 equals x times x plus 5 times x minus 2 all over x minus 2. And then the last fraction will become 6 times x plus 5, x minus 2 all over x minus 2 and x plus 5. Again, notice all of these denominators I did not change. I kept all of the denominators the same. The only thing I multiplied was all of the, or my whole least common denominator by each of the numerators. That's all that I did. From here, I'm going to get my fancy pen and I'm going to cancel. I'm going to cancel the x minus 2 in the first, x minus 2 in the second, and the x minus 2 in the third, and the x plus 5 in the third. So let me rewrite what's left. 2, didn't mean to make that bold, 2 times x plus 5, x times x plus 5, plus just a 6. That's the only thing that made it out of that last one. From here, we're going to finish by distributing. And we are definitely going to need to factor. So let me be clear on this next part. When I'm factoring, I'm not going to do the GCF because there's not a GCF that I need to take out. There's not a two-term problem where I can just factor out, for instance, like an x and then leave an x plus 3 that I need to solve. I don't have any of that. So I need to actually use the x chart. So we're going to find two numbers that multiply to negative 4 but add up to 3. Only two numbers that will do that are positive 4 and negative 1. And since your leading coefficient in front of the x squared is a positive 1, I can rewrite both binomials and then solve. So we'll have x plus 4 equals 0 and x minus 1 equals 0. So one of your x's should have been negative 4. The other x should be positive 1. Now for the fun part, we need to check. So of course, I already checked. So here's my check step. I checked them for both. So it looks like for x equals positive 1 right here, looks like both sides of your equation are going to match. So negative 2 is going to equal negative 1 plus negative 1. Negative 1 plus negative 1, guys, is just negative 2. So that's going to be a solution. And then all the way over here on the far right, for negative 4, I have this simplified solution down here. So you should have had negative 1/3 equals 2/3 plus 3/3. And the only reason why I rewrote it as 3/3 instead of keeping it as 6/6 is because I already know 6/6 reduces to negative 1. The issue is I still need to add it to that 2/3. So since I want to just try to find the exact same number but have a denominator of 3, I just rewrote it as negative 3/3 because negative 3/3 reduces to negative 1. So I'm not changing any values here. And yes, this side will match up with this one because 2 minus 3 is negative 1. So my other solution is going to be negative 4. Guys, please be careful with every question that you do whenever you're solving an equation. Equations are when you can actually use that least common denominator and multiply it by both sides of your equation. For expressions, you cannot use this method, guys, and I have students not pay attention and they're watching this at 1.5 speed, so they're really not paying attention and they will mess this up on a test or quiz. Whenever you're doing questions that are for expressions, do not multiply the entire problem by the least common denominator. You will not get a correct answer. For equations, you can do that. Expressions, no. Make sure you take time to do practice problems, and if you have questions, make sure you let me know.